So now we're going to get into lesson number 2, which is our SD-WAN components. In this section here, we're going to talk about the functions of the different elements. We kind of introduced what some of those elements were as part of our discussion in the first lesson. In this lesson here, we're going to talk about kind of in more detail what some of those elements do. We're going to take a look at the hardware in this piece as well. What are the different vEdge routers? And what is the vEdge cloud router? And then we're going to talk about the different deployment methodologies that we have as well in this particular lesson. So when we look at SD-WAN as far as an overall architecture, we talked previously about this overall architecture, and I talked about it kind of in 4 layers. Here we're kind of looking at it in 3 different layers. I had articulated the 4 layers before, but we're going to kind of break this down now into 3 individual layers. We're going to start from the bottom and then kind of work our way up. I'm going to speak to this kind of generically, and then we'll kind of go into more of the details that we see on the slide here. What you can really view is at your CPE side, right? The customer premise equipment side or the premise device. Previously, the existing routers or any sort of managed device that you have from your provider is actually what takes care of forwarding the traffic in a traditional design. Could be a layer 2 device or could be a layer 3 device that's moving bits from point A to point B. In an SD-WAN architecture, these are all distributed, and these are the ingress and egress points of the tunnels that you're going to utilize and encrypt through your transport network, creating various different types of topologies associated to those endpoints across the WAN. And like I said, we're not locked into full mesh. We're not locked into partial mesh or hub and spoke. We can use any type of topology. Of course, you're going to have your endpoints. Those endpoints are going to be your data centers, your branches, your remote side campus, maybe even some of your cloud assets, if you will. And they are going to be connected to some sort of physical transport. Now, the important part of SD-WAN is actually the transport. It's what provides you the ability to make different types of, or to take different types of transport and utilize them seamlessly and view them as almost like they're a singular infrastructure, right? So when we look at it, it's really about consuming things like Metro Ethernet, MPLS services, business internet services, LTE in some cases, or for some customers, leveraging some sort of maybe even a commodity-based internet type of connection. All right. The beauty about SD-WAN is that you get the power of using all of these different connectivity options simultaneously, and then you're able to then derive specific application-based policies to determine which path is going to be the best path for your particular SLAs. We kind of alluded to that in the previous lesson. So that the transport layer is really just the pipes, right, that we utilize in kind of a hybrid environment. And we're going to have a lot of variants to those pipes connected to our different distributed forwarding endpoints, or our vEdge endpoints in this case, that are basically just tunnel initiators and tunnel endpoints. Now, the top layer, we look at it from a control perspective. That's our control layer. The control layer typically within an SD-WAN architecture is the brains behind the entire design. It manages the configuration. It manages the control plane policies between all of the different distributed elements, but also associated at the top level, if you will, of the SD-WAN architecture are the automation pieces, right? We see vBond in this diagram. We see vManage and their vSmart controllers and vAnalytics, and maybe some third-party API automation, but that's really the top piece of this, of these automation elements. Zero-touch provisioning, for example, to facilitate the implementation of a particular site or auto configuration of based on particular business needs. Providing a management aspect, being able to actually look at the devices, configure them, take a look at any sort of analysis, like what are any of the flows doing in the network, what is the traffic doing in the network, and so on. So at a high level, there are three components to this. There is the controller, which provides centralized monitoring operations to transport to the transport layer, if you will, and that would include those distributed forwarding elements in the design. All of those provide connectivity in different types of topologies that you need, and that connectivity is going to range, right? Data centers, campuses, branches, remote sites, cloud assets are going to have different types of connectivity requirements. So overall, what we're trying to get from this is operational simplicity, which is going to include things like zero-touch provisioning, centralized monitoring and visibility, interoperability to legacy connectivity as well. You might have a hybrid WAN, which is going to be carrier agnostic. You might have MPLS, LTE, broadband, intelligent though connectivity, which is going to usually include some sort of active utilization. You're going to have some sort of application and cloud awareness, right? Application-based traffic steering, if you will, distributed analytics, multi-topology support per application. And then, of course, finally, the secure and routed infrastructure, right? Centralized control and distributed forwarding, secure connectivity between your forwarding elements, and then embedded enterprise-grade networking. So this, we talk about simplicity. It's really about making it so that you have as little touch on your network infrastructure for that particular WAN as possible. You want to be able to basically deploy a CPE or be able to automate the deployment of a CP, whether it's in a virtual form factor, but the idea is that you're not really physically touching it. And that's the whole concept of zero-touch provisioning, which we'll get into in a lot more detail later on. You know, you want to have that view being centralized, which is the control layer, right? That control layer that we've been talking about. There's another piece. If you want to ensure the interoperability with existing devices, it could be something as simple as connectivity options physically, or an integration of tool sets that you might be particularly using within your organization. It could be protocol usage. Maybe you guys utilize a specific protocol in your environment and you want to maintain that protocol usage. The hybrid WAN piece, like I said, it's really about giving you the power to look at the transport layer as an agnostic piece to this. You want to be able to support multiple types of transport to increase your bandwidth and also to increase availability and resiliency. We're getting to the point essentially where business internet and commercial internet is actually becoming good enough that you can actually drive certain critical applications and services like voice over IP. Traditionally, we would never consider that because of the limitations for quality of service and so on. SD-WAN helps you determine what is right, what is a good fit for me, based on a particular link for this application or another link I'm looking to use for transport that might not be good enough, so I need to make a switch, right? So that's the dynamic element, being able to switch from one transport to another. That's what really drives the whole concept of SD-WAN into this application cloud awareness. You want to have a level of integrated intelligence directly at the distributing forwarding layer, as close to where your users are, the applications are, and so on, right? You want to have that intelligence to the edge, if you will. So to actually understand and to be able to monitor those applications so that you can make intelligent decisions on how you want to reroute or maybe even re-forward traffic across your multi-transport infrastructure. That's where the blue cloud in this diagram provides that, the vAnalytics and the third-party automation and so on. All right. The analytics is really all about understanding what the traffic is doing in your network. It's really important because depending on the SD-WAN path that you take, there's a kind of a level of topology support on this per application basis, right? And different verticals or different industries might have different requirements. For example, in a point of sale system, right, that type of environment is more conducive to like a hub and spoke topology, where where if you're running, say, for example, voice over IP, that's going to be an environment that's more suited or suitable to a full mesh, for example. So you can actually derive different data plane paths based on those requirements specifically, right? The infrastructure that you want or that you deploy also has to have secure connectivity. You want to make sure that if you're using protocols like OSPF or BGP, you have a centralized control point, but you also have to distribute the forwarding that's associated to those particular protocols. So we have topology and segmentation support that's important in our SD-WAN solution. Key management between the endpoints. We might deploy infrastructure as a service or software as a service integration. Enterprise routing features are pretty important. Application awareness, of course, is a critical piece. Being able to insert services, different form factors, different transport options, and so on. So when you look at SD-WAN, there are a couple of things that you want to take into consideration when you're evaluating a specific vendor or evaluating the technology itself. I know this is a Cisco class, so we're talking specifically about the Cisco products and the Cisco pieces, but they're not the only players in this space, right? There are a lot of other vendors that provide SD-WAN solutions. So you have to kind of consider how they handle these different elements, right? So and that's what we're talking about. Is it how do they handle segmentation? How do they do key management? How do they integrate with infrastructure as a service or software as a service, and so on? All right. Now looking at this diagram here, the primary components of SD-WAN is vManage, the vSmart controller. So vManage would be something that we would define at the management plane, right? We talk about the management plane, the control plane, the data plane, and in this particular case, we have the orchestration plane. We're going to break down each one of these in this section here. That's kind of why I'm doing this long introduction, if you will. But where do these pieces sit in the overall architecture? The vManage NMS, that's the management plane. The vSmart controller is the control plane. The vBond orchestrator, which is that daemon that's integrated into the platform, that is going to be your orchestration plane, which is what you're seeing depicted here. And the vEdge router is going to be your data plane. So I know that we don't see all of these pieces on this slide. We see the vEdge routers and the vSmart controller and vManage and vBond. So what I want to do is I want to kind of talk about what each of these pieces are in more detail, right? The vManage, that's your centralized management system. Like I said, that provides you the GUI interface so that you can monitor and configure and maintain all of the SD-WAN devices, the links, the underlay, the overlay, etc. The vSmart controller, that's your software-based component that runs on a software platform. That's going to be responsible for the centralized control plane of the SD-WAN network, the centralized control plane. That's what allows us to establish our secure connection to each of the vEdge routers. It distributes the routes, the policy information, and it uses something called OMP. We're going to talk about OMP in more detail later on. That's another piece to this, right? We hadn't talked about that yet, but OMP is the Overlay Management Protocol, which is the one that I kind of alluded to previously. We were talking about route reflectors. That's what is acting essentially as the route reflector in this particular environment, right? It orchestrates the secure data plane connectivity between the vEdge routers by distributing things like crypto key information. We don't have to have an IKE environment, so we run an IKE-less architecture, if you will. And these are all kind of things that Cisco documents on their website about these particular pieces as well. Another component is the vBond orchestrator. That's what they're focused on in this particular case. That's a software-based component. That's what does the initial authentication of the vEdge devices. It orchestrates the vSmart and vEdge connectivity. It plays an important role because it enables the communication of the devices that might sit behind, say, a NAT device. So you see one of the bullet points is it facilitates NAT traversal. Highly resilient. It's the first point of authentication, etc. We'll talk more about that later on as well. And then at the bottom of the slide here, in the graphic anyway, you see vEdge routers. This device, like I said, can either be a hardware appliance or it can be a software-based router. It's going to sit at the physical site or in the cloud if it's a virtual platform. It's what provides the secure data plane connectivity between the sites over either a single WAN transport or over multiple WAN transports. You can see the three clouds in the diagram there, MPLS, iNet, and 4G. Those are just options for the transport itself. It's responsible for things like traffic forwarding, of course, security, encryption, if we're deploying some sort of quality of service. We run protocols like BGP or OSPF, Open Shortest Path First, on these platforms as well. So the orchestration plane the orchestration plane using Cisco vBond is a pretty important component, all right? Pretty important component to all this. So I know that's a lot of information for this particular slide here, but I think it's important, even if it's repetitive, to kind of see all of the different elements that we have here. In order for, and I'll just wrap up this slide with a little bit more information here. In order for us to deliver SD-WAN as a service using orchestration, we need an SD-WAN orchestration platform to control and manage those services, right? And that typically involves some sort of combination of an SDN controller, some sort of network virtualization software that allows us to automate and provision and operate the software and the elements in the network. And that usually would be based in the cloud. But the SDN controller, just like with any software-defined networking solution, is thought of as the brains, right? It sees the networks, and when we combine that with the components of the virtualized network, like maybe a virtualized infrastructure manager, we can manage those network resources. So the SDN controller determines what network connections exist, what cloud resources we're going to need for servicing the SD-WAN or the services themselves or even the applications. The orchestration process manages service chaining. That's another term that you'll probably see throughout the rest of the course as well. Service chaining is a process where we have several different services or applications that get linked together from the data center to supply the customer with the services that they need, right? Service chaining is how we perform the network function virtualization, or NFV, if you will, and that creates a VIM. So one of the main goals of orchestration is to enable customer provisioning. You can go to a web portal, in our case, vManage, and you can manage the services there. You might even be integrated to a third-party automation piece, right? We see that arrow there for the APIs. The third-party automation might allow you to subscribe to services, and then those services can be automatically configured and delivered within your SD-WAN platform. but the idea is that you're not requiring any human intervention, right? Now, you will have to have some sort of open kind of SD-WAN tools and protocols that might include things like RESTful application programming interfaces, some sort of automation configuration standards like netconf, Yang, or what we call Tosca, TOSCA. We don't see that listed here, but that's a piece to this as well. That stands for Topology and Orchestration Specification for Cloud Applications. So we don't spend a whole lot of time in this class getting into the third-party elements, but there are, it gets a lot more complicated when you start to consider a lot of those third-party elements. So what is vBond, right? vBond is the orchestrator of the system. Its job is to orchestrate connectivity between all of the other components in the system itself. In other words, it's going to tell vEdges where and how to connect to vManage and the vSmart controllers. And it's also going to advise vSmart controllers if new vEdges join the network, or the SD fabric in this case. It also serves as a role, to inform the vEdges if they're behind a NAT device. So that's, like the bullet point states, it's going to facilitate some sort of IPsec NAT traversal. So the authentication header security gets applied to the data plane tunnels. We'll get into the security piece in a lot of detail a little bit later on. So overall, vBond is really the first point of contact and the first point of authentication for every single SD-WAN component as they boot up and as they end up joining the SD-WAN fabric. The vBond application, they can be hosted on either an ESXi server or a KVM hypervisor. They can also be run as an agent service on one of the vEdge hardware platforms. Cisco doesn't really recommend this, but it can be done. And then each vBond is going to require a dedicated public IP address. All right. I know it's a lot of information. Trust me. It took me a while to kind of grasp all these different elements and how they kind of work together. But hopefully, I'm going to keep repeating myself, and I'll keep talking about these different pieces here. But hopefully, as we continue to go through this, it'll start to make more and more sense. All right. Now, vSmart is, as the name kind of implies, is really the brains of the system, right? This particular device, which is part of the control plane, the control plane, if you will, it actually is the control plane component of the whole architecture. vSmart controllers advertise things like routing information. They advertise data plane policies, security policies, and so on. They're typically going to be positioned as a hub device in the control plane topology. And then all of the vEdges are going to be peering with vSmart, or with a vSmart element, right? You can have multiple vSmart elements. But the vEdges never form any kind of control plane peering between each other, right? That's all the data plane transport happens between those endpoints, the vEdge endpoints. All the control plane stuff happens with the vSmart. So if you're familiar with like BGP route reflectors or like a DMVPN NHRP server, then that's what's very similar to like a vSmart topology. They never insert themselves. We talked about this in the last lesson a little bit. The vSmart endpoints never insert themselves into the actual data plane conversation. They just advertise standard reachability information, if you will. All right. So that's in essence what the vSmart piece is. All right. So the documentation and the courseware says, that the vSmart controllers are a scale-out control plane function of the Cisco SEN fabric. All right, so what does that mean, a scale-out control plane function? The vSmart controllers facilitate fabric discovery, and again, we use the overlay management protocol for that, and between themselves and the vEdge routers. They act as a distribution system for all of the information that's going to be required in order for us to establish the data plane connectivity directly between the vEdge routers. So remember I said it's kind of like a DMVPN NHRP hub, right, where we might do an NHRP redirect for spoke-to-spoke communication, or we might do a NHRP lookup and response and so on. Same kind of concept in this particular case. All right, what does this information include? It includes the service or the LAN reachability information, the transport or the WAN IP addressing, IPsec encryption keys, site identifiers, and other information. We'll get into the details of provisioning the vSmart elements later on, which we'll talk about all the specifics in that regard. But that we distribute any kind of data plane application aware routing policies to the vEdge routers. That provides the enforcement of the routing function. Control plane policies acting on the control plane information. Those are going to be locally enforced on the vSmart controllers, but then the policies can implement, like I said, that service chaining in different topologies. And the idea of the service chaining is that we're identifying what types of services are available, what links are necessary, or what links can be used to facilitate that service communication. All right. Now, the idea here is that we're trying to reduce dramatically the control plane load, which would be traditionally seen if you're doing some sort of large-scale IPsec network, right? The N squared, if you will, complexity problem that you see. vSmart controllers deploy, the deployment model that we use solves that scaling issue, but it also allows us to have high resiliency, high availability, and so on. Typically, we would deploy the vSmart controllers geographically dispersed, maybe in a data center, or we might have one central data center and one hosted in a cloud environment. But that's obviously to provide that physical redundancy and that resiliency. We don't want to have any kind of control plane failures. That would be really bad, right? So we would typically run them redundantly. If they're delivered as a cloud service, we can even run them redundantly in the cloud as well. All right. If you can run them on premise, you can run them in the cloud, or you can do kind of a combination, if you will, in this particular case. All right. Now, the vManage is what provides the management piece. It's a single pane of glass. It allows us day 0, day 1, or day 2 operations. We can deploy it as a multi-tenant component. So if we want to provide different services. The GUI itself allows administrative access. We can do RBAC, on the platform itself to identify who has access to what interfaces and so on. We can even integrate this with DevOps operations, and we can extract information about the network itself too, like performance statistics and so on the network, if we're looking to capture that information. vManage is basically, in this case, the network management suite or the network management system. It's your window, if you will, into the entire SD-WAN architecture. So it's the piece or the platform that you as an administrator would interact with on a daily basis, right? It's very similar to like a Meraki dashboard. If you've ever used a Meraki dashboard, you can think of vManage as in kind of the same light. It's basically responsible for collecting network telemetry. We collect that information from our vEdge devices, and then alerting you on events or outages in your SD-WAN topology. It's also going to be the location where you're going to build your device configuration, all your what we call device templates, and overlay your traffic engineering policies as well. It's the programming interface for REST APIs, if you have third-party integration, and so on. If you're doing this as an on-premise deployment, vManage is going to be hosted on either an ESXi or a KVM hypervisor. I can't remember the specifics. I'll quote some, don't quote me on this, but the last environment that we installed this in, I think it was 16 CPUs, maybe 32 gigs of memory, maybe 500, maybe 700 gigs of storage. So that's pretty significant when you think about deploying this within your enterprise. That's why a lot of people will choose to use the hosted option. And a single vManage instance supports up to about 2,000 devices, if I'm correct. And you can cluster different instances together. I think you can cluster up to 6 different vManage instances together. So from a scalability standpoint, it scales to a pretty large environment. All right. Any questions about this before I move on to the next slide? All right. So the next element that we talk about is OMP. And I mentioned this briefly before. OMP is the overlay management protocol. It's the central component. Well, they're all kind of central, I guess, but these kind of work together. But it's a central component of the SEN fabric. It's TCP based. It's a control plane protocol, and we'll talk about all the specific port numbers and the communication channels that have to be open to support this protocol. But it's our control plane protocol that brings together all of the control plane functions under a single kind of protocol suite, if you will. It's bidirectionally implemented. It's certificate-based authentication using either TLS or DTLS connections between the vSmart controllers and between the vSmart controllers and the vEdge routers. So vSmart to vSmart communication as well as vSmart to vEdge communication. So you can think of this, again, going back to that analogy of DMVPN, this is kind of like the NHRP component to that, right? It's what allows that communication. It advertises all the control plane information between the vEdge routers to allow direct IPsec communication between the vEdge routers without relying on some sort of internet key exchange. It allows the exchange of full reachability information without reliance on traditional routing protocols like OSPF or BGP over those IPsec tunnels, and it allows for data and application-aware routing policies to apply that enforcement, if you will, to the vEdge routers. So it's very, very scalable. It gets rid of, again, that N-squared concept that we talked about with IKE-based IPsec networks. It's really kind of the underlying control protocol, if you will, that allows this communication. All right, so OMP, it's actually very, very similar to BGP. So if you've dealt with BGP, policy-based protocol, OMP is very similar in that regard, and it manages essentially the overlay. Like I said, it runs between the vSmart controllers and the vEdge routers. Things like route prefixes, next hop routes, crypto keys, policy information. All of this is going to get exchanged over a DTLS connection. And remember I mentioned previously in one of the previous lessons, this route reflector concept. The vSmart controller is what acts like that route reflector. It's going to receive all the routes from the vEdge routers, all the processes, all the policies, etc., and then it's going to advertise that information to the other vEdge routers in the overlay network. If you don't have a policy defined, the default behavior, and we'll see this later on as we get into the implementation, but if you don't have an overall policy defined, the default behavior is a full mesh, meaning that basically every vEdge router can directly connect to every other vEdge router at any other site, and they're going to get full routing information from those sites. OMP actually advertises 3 types of routes. And I don't know if I need to get into this in this much detail right now, but I guess we will since we're talking about it here. We'll see this again later on as we get into the implementation. But there's 3 types of routes. OMP routes are the prefixes that are learned from the local side or the service side, which is the vEdge router in this particular case. The prefixes get originated as static or connected routes or from within the routing protocol itself. Could be OSPF or BGP. Those prefixes get redistributed into OMP. That's what allows them to be carried across the overlay. So OMP routes are going to include things like different attributes, like transport location, what we call TLOC information. TLOC is kind of like, if you're familiar with BGP, one of the major, well-known mandatory attributes in BGP is the next hop IP address for the route. TLOC is kind of like that in this particular case, transport location. We're going to also have other attributes like origin, originator, gosh, what are some of the other ones? Preference, a site ID, VPN information, maybe a tag, other kinds of things. It's like a separate routing protocol, right? A way of establishing routing information. The OMP route only gets installed in the forwarding table if the TLOC that it points to is active, right? That's very similar to like your standard routing, right? In BGP, if the next hop address is not reachable or if the next hop address is not active, then the BGP route doesn't get installed, right? So what is a TLOC route? A TLOC routes are basically the logical tunnel termination points on the vEdge routers that connect into the transport network. It uniquely identifies itself, or it's represented by what we call a 3-tuple. And again, we're getting into more detail than I wanted to, but you know what? Who cares, right? If you hear it more than once, that's a good thing, right? That 3-tuple consists of 3 things. That's by definition what a tuple is, right? System IP address, the link color, and the encapsulation. Am I using IPsec? Am I using GRE? And so on. In addition to the IP address, the color, and the encapsulation, those TLOC routes carry attributes like, is it TLOC private? Is it a public IP address? Site ID tag, weight, etc. Those things that I mentioned before. All right. Now we're going to also talk about the integration of BFD, bidirectional forwarding detection. We have a BFD session that automatically gets created. This is not something that you have to configure secondarily. It's part of the overall deployment of the SD-WAN. But in order for a TLOC to be considered active or in an active state on a vEdge endpoint, we have to have an active BFD session associated with that particular vEdge TLOC. Okay? It's a completely, I wouldn't say a foreign way of looking at routing in the SD-WAN, but we're not just using traditional BGP or MPBGP or IGP protocols to route information. We're using this OMP piece, right? And that's why it's really important that we talk about it as much as we are. Obviously, I've already kind of covered every one of the bullet points here. All right. We also have service routes. that's part of this as well. Service routes could be like a firewall, an IPS, some sort of application optimization. That would be part of the vEdge local site network. That might be available for other sites for use by inserting those services. We can include VPN routes, VPN labels, and so on. So there's a lot of pieces to this, right? So we'll get into it in more detail in a little bit, but like we're getting into the nitty gritty, if you will. We're going to talk about specific application elements for OMP. And we're going to take, when you do your lab exercise, you're going to be actually looking at some of these routing tables and OMP information and analyzing the architecture based on that. All right. Now, the data plane is the vEdge routers, right? The WAN edge routers that get positioned everywhere in our SCN fabric to extend the fabric, if you will, across the network. So the vEdge routers, like I said before, they're going to be doing the encryption, the decrypting of the application traffic between the vEdge to vEdge communication between the sites. We establish control plane relationship between the vEdge routers and the vSmart controller to exchange information that's required for us to establish the fabric and to learn all of those centrally provisioned policies that we talked about. Whether it's this is going to be a policy that describes the overall architecture, hub and spoke, full mesh, etc. And this is the data plane, right? Those application-aware routing policies that get implemented on the vEdge routers, that comes from the vSmart controller. And then we perform things like capturing performance statistics and analytics. We generate alerts if there's events. Those alerts are going to go to our vManage system, so we have our single point of management in that particular case. All right. Now, vEdge routers themselves, they're going to be using OMP, but they're also going to be using kind of your standards-based routing protocols like OSPF and BGP to learn reachability information from the LAN side, right? The LAN side is the non-SCN sites, right? So we have kind of a full stack of routing information, very simple routing environments, complex routing environments, etc., and so on. Now we can bring these vEdge routers online with what we call a full zero-touch deployment, which really just simply requires administrative approval. But we need digitally signed certificates installed for onboarding, and we have what we call a TMP, or a temper-proof module, that uniquely identifies that endpoint in the architecture, and we'll see that a little bit later on as well. All right, so the vEdge routers come, like I said, in a physical form factor. They come in a virtual form factor. They can have 100 meg interfaces, 1 gig interfaces, 10 gig interfaces if it's a physical form factor. The virtual form factor, those can be deployed in things like AWS or Azure using vCPE or UCPE platforms, using KVM or ESXi hypervisors, right? And we talked about that previously as well. All right. So the models themselves, there's actually many different form factors for the physical platforms. We have the 100, the 1000, the 2000, the 5000 models. The differences between them are really just the different interface choices, whether they support higher throughput, the data plane tunnels. Obviously as the models increase, you're going to have more throughput and more data plane tunnels that you can create. We can use ASR 1Ks, ISR 4Ks, ISR 1K router platforms as well, and with ENCS to do the SD-WAN stuff. Like I said, in order to join the overlay network, we need to establish a secure connection to the vManage platform so I can get my configuration. And then it needs to then secure a connection with the vSmart controller so that it can actually participate in the overlay network. That discovery of vManage and vSmart happens automatically. And it's accomplished by establishing a secure connection to the, if you remember, the vBond orchestrator. All right. ZTP, that zero touch provisioning, is an automatic way for us to provision those vEdge routers. The vEdge router will actually attempt to connect to a ZTP server when it's powered up for the first time. There's a URL, I mean not a URL, but an address that it has to connect to. Geez, I'm trying to remember. I believe it's ztp.viptela.com, and that's where it gets its vBond orchestrator information from. Once I get that vBond orchestrator information, then I can make my connection to vManage and vSmart to get the full configuration and join the network. So it's kind of like a four-step process. And we're talking about, again, the vEdge router platforms, right? The cloud platforms, the data center, campus, branch, small office, home office, etc. Number one, there's a minimal bootstrap configuration, and that's one way. Or you can go with the ZTP process, the zero-touch provisioning process. It's going to try to, the very first thing the vEdge router does is it attempts to authenticate with the orchestrator, and it does that over a DTLS connection. Once we've authenticated, the vBond orchestrator sends the vEdge router the IP address of the vManage network management system and the IP addresses of the vSmart controllers. The orchestrator also actually tells the vSmart controllers and vManage that this new vEdge router wants to join the particular domain. Okay, so we mentioned these four pieces before, right? These four critical elements to the overall SD-WAN architecture. And you can see now kind of how they communicate with each other. Then we go into step number two, where the vEdge router begins to establish a DTLS or a TLS session with vManage and vSmart. At this point, it tears down its session with the orchestrator. The orchestrator's process or piece is done, right? Because we get our configuration from the vSmart controllers and the policies driven from the vManage platform. Once the vEdge router authenticates with vManage, the vManage is what pushes the full configuration to the vEdge router if that configuration's already been provisioned. All right? Obviously, that would have to be done through the use of the templates and so on. The third thing that happens then is the vEdge router then attempts to establish a DTLS or TLS connection to the controllers over every single transport link. So it's going to authenticate to the vSmart controller. This is where we establish that OMP session. This is where we get to learn the routes, all the different prefixes, all the different TLOCs, the service routes, the encryption keys, the policies, etc. All right. And then lastly, the final step is we establish our IPsec tunnels to the TLOCs over the different transports based on the policies that were defined. If you remember, a TLOC is the way that we identify the endpoints, if you will. A TLOC on a private transport color is going to connect to the TLOCs on both the public and private colors. And we'll get into the whole color concept a little bit later on. And the TLOC on the public colors, they're just going to try to connect to the other public colors by default. Now you can override that policy, if you will. And like I said, we will get into this later on as we get into the implementation piece, but that's the default behavior. All right. Then the last piece, and we'll see this in this section as well, is BFD. Right? BFD is then going to run over all these different established connections, and that's what allows us to quickly, in a sub-second interval, identify, what kind of issues we might have with connectivity, if you will. All right. Now, what about these vEdge routers, right? These are obviously the routing components of the architecture. They're essential to the overall WAN deployment, right? The vEdge routers can be delivered as hardware. We're seeing a couple of examples of vEdge router platforms here. But they can also be cloud virtualized components. They can sit on the perimeter site, or they can sit in the cloud. Now, there are multiple platforms, and I think, let me see, did I skip a slide here? No, I didn't. But I'll kind of break down what these platforms are. I mean, obviously, you want to go to cisco.com to make sure you're getting the latest information based on what the latest platforms are, because that changes on a regular basis. But you've got OS-based routers, which like the vEdge 100, that's going to have, 5 different 10, 1000 ports. That actually comes in a couple of different options. In fact, let me flip to the next slide here real quick, and then I'll go back to this one. You've got the 100 itself. You've got the 100B, which is just an Ethernet-only platform. You've got the 100M, which has Ethernet as well as 2G, 3G, and 4G. You've got the MW, which has 2G, 3G, and 4G plus Ethernet plus wireless LAN. That's what you see here. And these are the specific bullet points for these. But like I said, you want to go to cisco.com to see the latest information on these different platforms. All right. But these are some of the platforms that exist. As far as the 1000 goes, that's going to have 8 ports of GigE using SFPs. You're going to have the TPM chip, the 3G, 4G, security QoS, etc. The 2000 has 2 pluggable interface modules, actually. So we see it's obviously a lot of port density here. 10 gig support as well, 3G, 4G. And then you get into the higher platforms like the vEdge 5000, which is going to have 4 network interface modules. The ISR 1100 4G has 4 gigabit Ethernet WAN ports. The ISR 1100 6G, that's going to give you 4 gigabit Ethernet ports and 2 SFP ports and so on. But I mentioned this before. We can also do iOS XE SD-WAN routers as well. ISR and ASR series. So like an ISR 1000, an ISR 4000, ENCS, which is an ENCS 5000 series platform. And then we have the cloud routers as well. So as far as the, what's supported, the vEdge Cloud, which is basically a CSR 1000V, and vEdge routers themselves, they're going to differ based on their functionality. The key difference between those platforms is really respect to throughput, redundancy, and so on, with the physical vEdge router platforms, as we've seen throughout, right, the slide here. And like I said, just go to cisco.com and search on vEdge routers, and you can see some of the different options. Okay, and it's constantly changing, obviously. Now, the cloud routers, the vEdge cloud routers, is a software platform that supports all of the capabilities of the physical vEdge router platforms. But the vEdge cloud router is offered as a virtual machine, and it can be deployed in a private environment, public environment. You can deploy them in hybrid computing environments as well, and it's supported pretty much on all of your major hypervisor platforms, right? The vEdge cloud router uses actually an Intel DPDK infrastructure. So it's basically like an x86 platform. It does AES encryption. For optimized IPsec security performance and so on. And there's a couple of use cases. A lot of people ask, well, why would I use the physical platform if I can just go with the virtual platform? If we're extending our SD-WAN into a public cloud environment, that's where you're certainly going to see the vEdge cloud router component. Or if you just simply want to run a virtualized WAN router environment, right? So the left side is your on-premise virtualized WAN router environment, whereas the right side is your extending into a hosted environment. So if a branch network has different pieces, right? We have to operate and maintain different elements and those virtual network functions that we talked about. And we can do that with what we call vCPE equipment, right? Virtualized customer premise equipment. The vEdge cloud router assumes that particular role. All right. Now, there are a lot of different intelligent inline and off-path methods for integrating these vEdge cloud routers with the rest of your vCPE elements. And that includes things like routing, policy-based routing decisions, bridging, if you will, service insertion, and so on. We can actually deploy these just like our physical platforms. We can deploy these as active-active pairs using either OSPF or BGP. Or we can deploy them as individualized platforms. The cloud routers are supported on Amazon's Elastic Compute instance types, what we call EC2. And if you're familiar with AWS, there are different instance types. Cisco recommends M4.large or C4.large or C3.large in that particular case. Okay? All right. Now, when it comes to the controllers, the same thing applies to the controllers. We can do on-premise or we can do hosted controllers. And the controllers themselves, we already talked about what their overall role is in the topology. But they, like I said, they can be deployed as a on-premise or hosted solution, right? This is the NMS, the vBond, the vSmart controllers, all of this stuff, the vManage, vBond, and vSmart controllers. They're all going to run on virtual machines in your network, and whether you decide to deploy them on-premise or hosted really depends on what your overall environment is. But the resources required for running vManage NMS, vBond, vSmart controllers will vary depending on how many sites you're deploying, what does your overlay network look like, and so on. So again, I would recommend taking a look at the documentation to really see, what's going to be specific or applicable to your particular environment. All right. So that concludes this lesson. In this lesson, we talked about the different SD-WAN solution elements to create the virtualized network. We talked about how the virtualized network runs on an overlay on vEdge network routers or vEdge routers. How the centralized vSmart controllers kind of oversee that control plane of the SEN fabric. The vBond orchestrator authenticates all of the SEN devices in the overlay network, and then vManage is our centralized platform to deploy the configurations and policies. We also talked about the hardware platforms, vEdge 100, 1000, 2000, mentioned a couple of the iOS-based platforms as well as the 5000. And then we also talked about the different deployment strategies, whether we decide to deploy them on-premise or as in a hosted environment on AWS or Azure. Okay? So we'll wrap up this lesson. We have one more lesson in this module, and then we're going to wrap up the module. We'll see you guys in the next lesson.